Hey guys, welcome back. And in the last couple videos, we were covering some NFT stuff, and we're actually going to continue doing that. But really quickly, I wanted to actually cover a super important Solana topic that we haven't touched on just yet. That's going to be really important for both our NFT stuff in the future and also for pretty much anything on Solana. I mean, guys, this is one of the building blocks of building on Solana. If you can understand PDAs, you can build just about anything on Solana. So the infrastructure of Solana leans pretty heavily on these things, and they expect you to use them for your data, and this is why. So they make it pretty easy to store and retrieve data about a particular thing, right? So if you look here, we've got a couple wallets on the left. And let's take a look at just wallet 1 for now. So what we're doing here, what we're going to build in this example, is we're just keeping like a balance of different color tokens. We're not going to do any token accounts or anything crazy. We're just going to keep some data about a particular color token. So you got like a red token, a blue token, a green token. So the way that this works with PDAs is we'll have our program here, and the program will actually own all the accounts that are going to have the data in them. And we've seen something like this before with the token program, but the way things work with PDAs is it's actually an address that's derived from seeds, which are going to be these colors. And you can see here is the pattern we're going to use to derive it. And program derived addresses don't have a private key. So that's super important to remember. They don't have private keys. There's a whole like elliptical curve that Solana uses to make sure that it doesn't have a private key. I'm not going to dive into all that, but Solana has tons of docs on it. But the point is, it doesn't have a private key, so it doesn't need to carry a key pair with it to sign. In fact, the program can sign for it. So why is that important? Well, it allows us to do exactly what we're going to do in this example, store data in them, and use the program to modify that data. Now, the key is, as you can see here, like we're passing in a color, and if we just add the public key with a little underscore for security, and then the color, that's going to be the seeds that we use to generate this PDA. And so it corresponds to whatever color you're working with. So here's an account that corresponds to the red token for wallet 1, right? Blue token for wallet 1, so on and so forth. And this is supposed to say wallet 2. But anyway, point is, we can access this data from the program or from the client. You know, because as long as we have that seed and we have that wallet key pair, or at least the public key, we can derive that address and we can go look up its data. So that's another important piece, is you don't necessarily need to go through the on-chain program just to read or do stuff with it. To write, you do, but to read, you don't. So anyway, let's go implement this in some code and see what happens. So I just popped open a terminal here, and we've been using Anchor, so why not continue using Anchor, right? So I'm just going to init this project, PDAs. And while that's running, I actually want to open up another terminal, and if you guys want to try this, if you can get the Solana CLI installed, this should work out of the box. If it doesn't, you might have to do a little research online to find out why, but thankfully it worked for me. But if you noticed in the last video, let's take a look at our configs for a sec. Notice that my config is this local address, and I'm pretty sure when you first download the CLI, it may already be set to this, I'm not sure. And we saw in the last video that Anchor already sets up LocalNet as your cluster. This is why. If you have the CLI and this is all properly set up, you can actually type Solana test validator in a separate shell, and that'll actually launch a Solana validator on your local machine. And so it'll simulate its own cluster, basically. And so there's your JSON RPC URL, just like as if it were DevNet. So instead, this is localhost 8899. And the nice thing is, this is a little bit quicker to do RPC calls and to process transactions and stuff, so it helps when you're developing locally. So with this running, we're going to stick with the local setup, and I'm going to actually go into my setup here, and we're going to open it up in code. So since we're using LocalNet, we obviously don't need to go change Anchor TOML. This looks good. Default program ID for now. Sounds good. So just zoomed in a little bit real quick. We're going to go to our program here. Now, this is the boilerplate, obviously, that we get, but this is actually pretty similar to what we're going to do, right? Like we did this with NFTs. Like we saw the structure is pretty much the same. But let's set up our first function. We're going to do create ledger. And I'll create a little bit of room here. And all we're going to pass in besides the context is going to just be the color. It'll be a string. And now I'll also copy this. And I'm going to create this function, modify ledger. And instead of a color, I'm actually going to pass in a new balance. Just of a U32. And we're just going to be overwriting the balance. Like we're not going to do anything particularly crazy here. So our structs are going to be create ledger and modify ledger. And so down here, we're going to have create ledger. Whoops. And I'm going to copy this to do modify ledger. And finally, we're going to do our data account, which is just going to be ledger. And so this is going to be the one that houses the data that's in our PDAs accounts. And so the fields, we're just going to do the color, and we're just going to do the balance, right? So this is just the data we're keeping. What color is this corresponding to, and what's the balance, right? That's it. For modify ledger, to change one of these accounts that are represented by a PDA, that are owned by the program, all we have to do is pass in this account mute. These are going to be the accounts we have to pass in. So we'll do ledger account. And before I forget, got to add this bad boy up here to each of these. I almost forget to do that. And it's going to be of type ledger, of course. And then our next one is going to be just our signer. So we're going to have the signer, and that's just going to be the wallet. Right? Pretty straightforward. Now we can copy this in up here and actually set this up in a similar fashion. But since we're creating an account, we want to actually also add the system program. And that's of course going to be program. Put our lifetime guy in, system. And now here's the key difference, right? Like these are going to look exactly the same. This is what's cool about this. Like if I go like this and do this cool little trick, like this is the same as what we've seen in previous functions with Anchor in the last video. If we say let ledger account equal borrow mute context dot accounts dot ledger account, that's going to be how we start both of these functions off. Like they look exactly the same right now, other than the differences in instructions. They look exactly the same. What happens to create a PDA, at least with the example that we're going to show today, is Anchor actually can do this under the hood. So we're going to take this mute out. We'll still be able to borrow it mutable, but we're instead going to add this keyword init. And that tells Anchor, hey, initialize this account. And in this case, it's going to be a PDAs account. So we're actually going to be able to provide the seeds as well. And so we'll get to that. When you use init, you need to provide a payer. So we'll make the payer the wallet. And we also need to provide the space. I'm going to just do 82 for the space. And now here's the seeds. So what are our seeds? Well, we know from the diagram that our seeds are going to be the wallet public key plus an underscore, and that's for security purposes, and the color. And we have all that chilling in here. So we're going to do wallet.key as ref, because it has to be in bytes. And then you can use the B shorthand to put a string slice in bytes, which we'll do with the underscore. And lastly, we want the color as ref to be our third seed. And whenever you include seeds, you got to add bump. Now, where does color come from though? Like we're passing it in as our instruction up here, but Anchor doesn't know down here to use it without adding this guy. We just add instruction, color, string, and that will actually match this instruction color to the one that comes in as an instruction. So pretty cool. And now we can use it in here. So this is actually all we need to initialize this account. And it's really pretty neat if you think about it. But it's important to understand what's happening. Anchor under the hood is going to go and initialize this account. The wallet is going to be the one who pays to create it. It's got a specified space. and it's validating that this is the PDA, this is the address to that account. And then, of course, it's mapping it so we can use the ledger data type that we've specified here. And then up here, when we modify it, it's actually being checked. Since it's being borrowed as mute, there's no init, it's being checked that it exists already. And we'll be providing the address in both these situations. So up here, which is interesting to know, of course, because these look exactly the same, we're going to add just a touch of differential logic here. So in the top one, we're going to set, of course, the color equal to the color we're passing in. And we're going to set the balance equal to 0 to start. And then down here, we're going to actually set the balance to be the new balance that we're passing in, and that's it. So pretty straightforward, pretty simple operations going on here. We're just overwriting the balance. We're not doing anything crazy. But this is where all the magic is happening right here. So this is a super important concept to know, and one of the most interesting features of Anchor so far, at least on the Rust side. But anyway, this is it. We're done. And we'll come back to this guy later, but we're done here. This is all the Rust code we need to write. This is our program. And now if we go into the tests, we're going to actually set this thing up. And I've got a couple of like helper functions here. So don't mind if I just kind of like spit these in here. But I'm going to drop the first one here. It's going to give us just a substring of a public key. So we can just like print it out to the console without it looking too messy. I'm going to set my provider. And I do it this way so I can use the provider in functions, which I guess you guys will probably see shortly. And then here's our program. And so there's our Anchor configs to start things off. Now, the first function I'm going to include in our test scope is going to be this generate key pair function. And I'm going to actually paste it in there. You guys have seen this kind of thing before. All we're doing is generating a key pair from the key pair type. But we're also going to get an airdrop of 2 SOL, just so that thing's ready to go, like we have some SOL to test with. And then here, I have this little like sleep function, because if you're using DevNet or like any other cluster besides your local net, it kind of yells at you if you do too many airdrops close together. So this is a nice little buffer to have there in case you need it. So anyway, we'll do that. We'll generate a new key pair, set it up with some SOL. And now here is the key function that we're going to use. This is the one that we've been banging the drum about. This is how we're going to derive the PDAs. So we're going to do a function. We're going to call it Derive Pda. And all we're going to need to pass in, of course, is the color and then the public key of that wallet that we're using. And so now that we got that set up, here's the function that we use from Anchor. It's going to return to us the PDA and its associated bump. And the bump is really to prevent like collisions. Like if it can't create a valid PDA, it'll bump it by like some increment. And you can get that value here. We're not going to use it in this video because it's a little complicated, but it is important to understand what it's doing. So anyway, we'll do anchor await anchor.web3.public key find program address. And this is going to be the one that's going to create for us a PDA. And so it takes the seeds as a list, and then it takes the program ID. In this case, it's going to be our program ID, right? That's the one we want to own it. And now that's all done, and we're going to return the PDA. So what are our seeds? Well, we already know what they are. We already built them here, and we talked about them in the diagram. It's going to be these 3 things right here. So we're going to set that up on this end. This time it's going to be the pub key. And you have to make these buffer. So we're going to do 2 buffer. Then we're going to do buffer from underscore, of course. And then we're going to do buffer from, again, color. And so that gives us our seeds right there. Same as what we've got on the Rust side, on the on-chain program. Same thing on here. And this is what I meant about how you can derive this thing from the client side or the on-chain side. Like we're asking Solana to derive this for us, but we're not hitting our program. Like we don't need to hit our program to do this. So pretty cool, pretty important. And so as you'll see soon, we'll be able to actually use this PDA to retrieve the data. So we'll go ahead and move forward here. Here I'm going to set up a function to create a new ledger account. So this function's sole purpose is going to be just to go hit this guy here. Pass it the color, pass it the accounts, and run this thing so we can use this to initialize a new ledger account. So to pass into that, we're going to do color string. We're going to do the PDA, which is going to be a public key. And we're going to do the wallet, which is going to be, of course, a key pair. Drop these down a little. And now that this is set up, we'll go ahead and do await program.methods.create ledger. Just pass in the color. .accounts. What are our accounts going to be? Well, our ledger account is going to be the PDA we're passing in, and then the wallet is of course going to be the wallet.public key. We'll have some signers. That signer is just going to be the wallet, and .rpc to get us kicked off with an RPC call. And that's it. That's all this create ledger account's going to do. It's just directly going to hit this method that we've created, and we're going to go ahead and create the new ledger account. Now here's going to be the function where I'm going to put in a bunch of like debug messages so we can see what's going on. This is going to of course be our modify ledger one. And this is going to do the same thing as this really. It's going to go hit the modify ledger endpoint or modify ledger function, whatever you want to call it, and it's going to run this. Of course, as we talked about, Anchor is expecting these accounts, especially the PDA, to have already been initialized. So we're going to talk about how that looks when we go to modify the ledger. And just like for posterity, this is what our test is going to look like. So to give you guys some context, like we're just going to run the test like this. So modify ledger is going to have all of the meat and potatoes here. So in modify ledger, we're going to pass in the color, as you can see down below. We're going to pass in the new balance that we want to set it to, and we're going to pass in the wallet. And with those passed in, I'm going to add, like I said, it's going to be a little bit of like logs to put out. So I'm going to add this line as a separator. We're going to initialize a variable called data. And then we're going to do PDA equals await derive PDA, the color, and the wallet.public key. And of course, this is going to do exactly what we set it up to do. It's going to run this and give us that PDA on the client side. And so with that, we can go ahead and use this next command that we're going to run to try to retrieve the data. And the reason I say try, and here's a little log statement, is because if this fails, that obviously means that the account doesn't exist. So we're going to put in a try statement, and I'm going to say data equals await program.account.ledger, and this corresponds to the ledger account, right? Like Anchor will do all this for you, and it's not working right now because I don't have an Anchor build going, which I guess I'll kick off. But you guys can see, like in this account module of Anchor's program setup, it'll store actually the account structs that you got going on here, and it'll go ahead and let you do this .fetch call, and you can pass in the PDA, and it'll go try to retrieve that PDA's data, and it'll come back in the format of this struct. So super helpful. And we're going to put that in a try block, because if we can get that with a passed in PDA, or with a passed in wallet that we use to create a PDA, if we can get that, then we know it exists and we can just use its data. So here we're saying we're checking if that account exists. And then down here, I'm just going to put console log it does. So it does exist. And then for our catch statement, we're going to do the same kind of thing, right? So we're going to say it does not. And then we're going to create a new account. And that's just going to be using this function up here, right? So we're going to pass in the color that we're getting, the PDA that we genned, and the wallet that we're getting. And then lastly, we'll obviously try to grab that data again now that we've gone and created it. This will come back and give us the data. So this is how you get it though. This is how you pull that information back. So with it, when we move down here, and I'm going to add a whole chunk more of debug messages, and you'll thank me later. So just some printouts. The last thing we want to do is, now that we know for certain from this try catch block that our account exists, that our PDA has a ledger account, we know for certain. And as you can see, we're actually printing out the data here and stuff. So in our test, we'll know if that fails. Now is when we want to hit our modify ledger function on the on-chain program. So we're going to set it up the same way we did the create one. This time it's going to be modify ledger, and you can see them starting to appear in the autofill because it looks like maybe this finished without errors. Yay, it did. So yeah, again, just quick point out, like if you type this in VS Code, like you'll get some of this stuff as an autofill. Sometimes it helps. But anyway, modify ledger, we're passing in the new balance as we set it up on chain. For the accounts, we're looking at ledger account, and that's going to be the PDA that we gen, and wallet. Our signers, again, just going to be the wallet, and .rpc, of course. And now that that's set up, I want to just pull the data one more time after we've modified the balance. I just want to go ahead and add some more debug stuff. So all right, now that this is all set up, as you can see, this is how we're going to drive it. We're just going to create a new key pair. We're going to get that airdrop as part of this operation, right? And then we're going to use that new key pair to try to modify the ledger of how many red tokens we have. And since in this case it doesn't exist yet, it's going to be 0 because we're going to go create it. It's going to start at 0. And so we're going to add or change it to 2. And then here, that account will already exist and we'll have a balance of 2. We're going to change it to 4. And then same thing as the first time, but with blue. And then we're going to run it all over again with a new key pair. So pretty straightforward. The key pieces of this are obviously going to be the fact that we can derive this PDA without hitting our program. And then we can use it in our function as like a check. Like, hey, does this exist yet? No, it doesn't. Yes, it does. And then most importantly, we can get its data. And we can use it on the client side. And then this stuff we've seen before, we're just going to hit our program. So anyway, that's all done. And let's let this rip. So we just did anchor build and deploy. We got ourselves, well, I just did anchor build. I'll do anchor deploy. And we'll get ourselves a new program ID. And so with that new program ID, we'll go ahead and add it here. And we'll add it here. And we'll do anchor build and anchor deploy and anchor run test. And I'll see you guys when this is done. Actually, I'll do this. And now I'll run anchor run test in case we missed it. Kick this thing off. Here's our test. And as we step through, you can see what's going on. And we'll scroll back up when this thing's done. But you can see all of our outputs here. We get successful run. Let's take a look. So this is obviously going to be the first few characters of our key pair that we gen, right? With that short key printout. So we have red. It does not exist. We're going to create it, successfully created. We start with 0 red tokens. We change the token balance to be 2. Now we have 2. See this new data. And then here it's 2. We change it to 4. But notice here, like checking if account exists, it does. So we skip through that, right? And so on and so forth. You guys can see that we're changing the balance successfully. And even when we change key pairs, like as soon as we change key pairs, it doesn't exist anymore, right? Like here we had a new color. It's blue, so of course it needs to be created again. But up here we're using the same key and the same color. It already exists. And this might seem redundant, but I'm telling you, if you guys can wrap your head around this, it's going to be extremely, extremely useful. And I just noticed as I was explaining this is actually the first few characters of the PDA, not the wallet. But either way, the point still stands the same. These 3 are going to be wallet 1, and then the last 2 are wallet 2. But this is it, guys. This is PDAs, and Anchor makes it super easy to make, right? Like they had this whole init syntax here, and you can use that. And it comes in really, really handy. And as you can see, we've really just unlocked the potential for indexing data on Solana and using accounts that we can derive and go get data from at any kind of moment in time. Like if we want to do it from client, if we want to do it from program. So we'll see that in the future in stuff that we're going to build, and it's going to come in really, really handy.